Team, I suggest we start drilling operations. What do you say? And if we start with drilling, which areas are most promising in your opinion?
In order to find the most promising zone, we first need to identify which surveillance we would need to perform, for instance. We would have to figure out if there is channeling and whether or not unit B1 is production or the channeling or extending along the entire area. Let's clarify it. Also, I would like to note that the workovers on pressure maintenance will be more effective than drilling producer wells.
We would first need to prepare a list of activities that will have to be made, and after the economist has made the relative calculations, we will understand how much fund we have for allocation. So far, we have $2.35 million.
I would like to pose a question to the simulation engineer. Which wells are most promising in terms of performing reservoir flow profile?
If we are talking about the northern part, these are wells 107, 108. If we are talking about the southern part, then the wells E3, 126, 132 and 138. We don't necessarily need to survey well 132, but it still has a huge potential that has been lost for some reason. This may be a different reservoir thickness or different permeability, but at least with that thickness the permeability doesn't match the open hole data. It can differ 5-10 times.
So we suspect channeling.
Let's start in ascending order with wells 107, 108. I absolutely agree that they are promising. From a development point of view, these wells are important. I also agree with the statement, which means that 107 has a slightly different injection from the new natural depletion.
If I understand correctly, our strategy is to increase the pressure in the northern block. And do we plan to do it with the help of workovers? Should we close the channeling? And also, are there going to be any further activities aimed to isolate the highly permeable reservoir? And what kind of surveillance do we need there? Or we are just going to close reservoir B1 all around?
I propose to close B1 as a whole, or simply sublayer B1, according to existing reservoir flow profile results, or well flow profile, or according to future ongoing studies.
Currently, the channeling has been identified at the upper northern zone in wells 101 and 103. We can assume that if the wells 101 and 102 are similar, then they probably have similar injection in this zone. Therefore, it is likely there is also a channeling present at 102, and there is a definite after hydraulic fracturing. Maybe when we perform remedial jobs, we will conduct water gas shutoffs on these wells. Then we can also cut off the overlying unit B1.
I agree. It's worth doing.
Which wells are currently on the activity list? If I recall correctly, it's wells 101, 102, 103, right? Since we target the northern block, these are the all channelings, and also those mentioned by the reservoir engineer, 107, 108, 138.
Overall, since we already have the preliminary results, which show reservoir flow profile or well flow profile, we can already start water gas shutoffs.
So you propose to target the northern block first, or do you want to do some of the activities on both?
I propose to perform activities on the northern block and on the southern block at the same time.
Then it may be worth to prepare a list of necessary activities, and then we will ask our economist to evaluate the economic efficiency. If I understand correctly, the activity list has already been formed. Is that right, reservoir engineer?
Unfortunately, I only have a list of all possible activities. And of course, we will not be able to perform all of them. We just need to select the key activities and agree whether we should focus on the southern block or on the northern block, and which of them has a higher potential.
I think we can't do without an economist anyway. We would need to calculate the activities on either one or of the areas.
Yes, I completely agree with you.
I propose to prepare or provide 3 workovers to the economist which are confined to surveillance and see where we will have more efficiency. Then we will first focus on a better zone in terms of residual reserves.
It seems to me that we first need to carry out surveillance and figure out how the production is like at each of these zones. What is the reservoir pressure there? Then, based on the surveillance results, we can make a decision to either drill a new well or perform workovers. As mentioned earlier, we have missing intervals at bit 2, low reservoir pressure. To answer these questions, we would require some kind of initial data. Currently, there is not enough data to assess the potential. In order to assess this, it is necessary to conduct production logging and surveillance aimed to determine the reservoir pressure.
I see. Can you please suggest the promising wells?
My suggestions are wells 107 and 108 at the northern block can be surveyed for channeling.
So we can play them right away.
Yeah, sure. Let me just add to that. Perhaps this well, as well as E3, 126, 132 and 138, should be checked for channeling. We will identify it somewhere, and then we will make appropriate decisions. And in order to assess the potential, of course, we would require the information on reservoir pressure.
Do you propose to perform reservoir flow profile on all 6 wells at once, at the first shot?
Yes, because, for example, in the northern area, there are wells which already have cross-flow behind casing. For example, E4, 101. I believe well 102 is exactly the same as the well 101. There is also a channeling in well 103.
At least 6 of these wells, which were named, can be surveyed right away.
How much will it cost? At the same time, we will understand reservoir behavior.
I agree. Let's start with surveillance. I support this decision. Let's start with well 107. Then perform reservoir flow profile since it is an injector. The cost does not account for round-trip operations. Well 108 is a producer well, so the round trip should be accounted for. Can you also state the potential candidates for the Southern Dome?
E3, 126, 132, 138.
A total of 11,700,000 rubles.
Maybe we should also carry out stimulation right now to minimize the cost.
I suggest that we first create a reservoir flow profile. And after that, we can understand which wells can be used as the reference wells, which are free from various behind casing flows. Based on the list of wells, we can already measure the reservoir pressure and understand the field energy state.
First, we make a reservoir flow profile, and in case of channeling, we measure the reservoir pressure.
So let's make a decision, either to perform water-gas shutoffs on these wells, or we can use them for measuring reservoir pressure. Team, we have conducted surveillance, and we acquired some results. Let's review them. Let's start with well 107. We have identified behind casing circulation from above and below. Is the production logging specialist here? Can you comment on this?
It is evident that in case of well 107, the vast majority of injection goes into the aquifers and sublayer B1, where B3 is almost out of operation. Some crossflows occur in well 108, coming from the aquifer into the target formation. We can also observe a highly permeable sublayer in the formation B1, and the formation B3 is also out of operation. The channeling is absent in well 126, and all production comes from the sublayer B11. The channeling is also present in well 132, and almost all injection goes into the aquifer. Unit B3 makes no contribution.
As I understand, the perforation intervals and the effective thickness of production logging are the same. This is not the case here. Is the effective thickness lower than perforation thickness?
Even accounting for the perforated thickness, The well model was not adjusted to the actual data. If we normalize the production, which was initially, it is clear that based on the available history data and open hole data with a permeability of 300 million jerseys, results in the maximum flow rate of 60 cubic meters. However, the value we received is much higher. I believe that if we get rid of channeling now, then the zone where will be quite good and we can start working with it. This is the question is about the permeability of the reservoir and the barrier between them.
So you think that as soon as we close the channeling, all the water will be redistributed according to the permeability and reservoir pressure?
Yes, the thing is that we have units A, B11 and C with a huge permeability. If we isolate this subunit now and perhaps the entire unit B1, we will get an inflow from the unit B2. Well 132 was transferred to injection only about 2-3 months ago, and we can transfer it back to production. This is the well that was producing 50 cubic meters per day.
Then this is the first candidate for water gas shutoff, and after that we can transfer it.
That's right. I suggest we move on. We have the result of well 138. Let's review and comment on it. It is evident that there are no behind casing circulations here. The main work is carried out by a highly permeable sublayer B1. The main inflow is just water, and inflow from the other sublayers are oil or oil and water.
Here we have a typical situation where the top of unit B11 is highly permeable with the water flowing through. But since oil is lighter than water, therefore the water breaks through the lower part of this subunit. There is still a small part of oil left on top, and if you look at the total volumes, this is just a marginal volume compared to the volume of water that it carries. So in terms of performance, I recommend to shut off this subunit. That's why this well posed an interest. This means that there are undeveloped reserves for both the unit B1 and the bottom part of the unit B2. If we trace this story to the southeast, there might be reserves as well.
Then I have a question about this surveillance. Can we already call reservoir pressure measurement, or will it still not be very accurate and show a weighted average pressure information B11, or we expect a slightly different reservoir pressure information B2? How do you propose to measure the reservoir pressure, along with B1 or without?
Well, testing was already performed at this well in 2014. I believe since then the pressure has not changed much. The observed pressure in the well area is 110 bars. The question is, if this only happens at unit B1, or does it expand laterally? Probably just at B1. I believe we must first isolate the highly permeable subunit and run production from the underlying units.
And on the southern dome, where most of reserves are located, do you also propose to isolate zone B1? Perhaps we should produce it for a year first, and if water breaks through from below, that zone can be isolated. At least we would recover some of the reserves.
Is it possible to calculate this using economics? Calculate the option to shut off the formation B1 completely and optimize the production targets of B2? Or we can use the current perforation intervals?
What well are we talking about?
The dome part of the southern arch, wells 130, 133, we will isolate B1 and optimize the production targets at B2. What will have a greater effect? Which one?
Let's take a look. We can consider well 132. If we isolate the unit B1, the rate will be around 20-21 cubic meters. If we isolate only the top part, will we be able to carefully select the production targets and not break through the top? I believe the technologist can tell us what the minimum threshold is there.
The minimum threshold for downhole pressure is 45 bars.
If we consider the operation of this well, the bottom hole pressure was at least 60 bar. Do you think that 45 bar is the optimal pressure?
I'll recalculate it, but according to my calculations, this should be the value. We have a 5-meter barrier between layer A and B1. The pressure in layer A is 130, or is it higher?
It's 160.
I will correct the calculations. Do we assume that there is a hydrostatic pressure in the water-bearing formation A?
That's right. We have a choice during the first approximation. Despite all the teeth injection, we assume that there is hydrostatics.
I recalculated the bottom hole pressure and it's 61 atmospheres.
Perfect. We need to keep a very delicate production target for well 132. We must proceed with caution and keep a bottom hole pressure to 65 bar, but also perform relative calculation, so that we don't break through this subunit again and get pure oil.
Can I clarify our strategy? We keep the reserves of B1 at the dome of the southern arc, if possible. In all other areas, for instance, the northern part of the southern dome and the entire northern dome, we completely close B11 so that we can optimize the production target. Reservoir engineer, do you approve of this strategy?
Yes, I approve. We have not yet reviewed well 138 and the E4 surveillance. Let's review it to understand the processes completely. So, we have reviewed well 138. Well E3 is an injector. I ask the specialists to comment on the situation regarding this well.
Here, the behind casing circulation goes into the layer A. The operation of layer B is insignificant and is rather poor.
If I correctly understand, all of the water either goes through the unit B11 or entirely misses the target unit. May we assert that along the entire zone, which is located to the north of the well E3, we should only use the strategy which involves isolating the top part of the unit B1 or unit B1 entirely and finalize the shot on unit B2, where it is not completed, and develop with B2?
For certain wells, I propose to completely isolate B1. We can shut in B1, a less permeable sublayer, in producer wells. What do you think?
Actually, the situation is that if we optimize production targets and evaluate all the barriers between the unit top and the main unit B1, then this should not be a problem. But if there is going to be lots of injection, then this might be a problem if we still want to produce from unit B2. And since we have time and resource constraints, it seems to me that it will be better if we shut off the B1 and spend the next 5 years on unit B2.
I support the strategy. Since our main goal at the moment is to achieve maximum financial efficiency during these layers. What do you say?
I suggest that we perform economic calculations and then approve the strategy. Economists, please evaluate these two scenarios.
We will perform the calculations with the economist. I will provide the production rate, and the economist will calculate the indicators. I propose well 126, that already has a reservoir flow profile.
We will calculate the economical parameters and extend it to all the remaining wells. Well 126 is one of the options without water-gas shutoff, but with the forgiven production targets, and the second option with water-gas shutoff and maximum conformance control.
We should also assume that B2 has been completed in both scenarios because the well only operates in B1.
Agree.
So, if we leave the well 126 with B1 on very gentle production targets, we'll be able to produce 30 cubic meters.
Is this without accounting for the perforation?
No, this is with the perforation.
Can you tell the oil and water production rate in cubic meters?
Yes, please hold on during perforation. The oil production rate is 30 cubic meters. The water production rate is 60 cubic meters.
Copy that.
Now, if we shut off the unit B1 and make all optimizations, 1 cubic meter of water and 42 cubic meters of oil.
Do we also take into account the costs of all types of activities?
Yes, the perforation depends on the depth in meters, and water gas shut-off depends on the number of intervals.
Petrophysicist, please state the perforation interval.
1633, 1647. Additionally, we can perforate the interval 1653, 1660.
This results in 14 meters for the first sublayer and 7 meters in the second sublayer.
Is the water gas shut-off is performed for one interval?
Yes, that's right.
Economist, if you have visual material, you can demonstrate all of this on the screen.
While the calculations are being performed, I propose to conduct a surveillance.
I suggest we first start with measuring the reservoir pressure.
To save time, we can determine the data points for measuring the reservoir pressure.
Yes, we had a list from a simulation engineer and a reservoir engineer.
Simulation engineer has a more extended list.
Yes, this is due to the fact that sometimes the formation pressure was higher than initially calculated, or the pressure was dropped. For example, in case of well 122, the formation pressure, according to the well testing, was around 114 bar, while according to the model, it was not higher than 65. The fact is that there are huge losses.
I propose we measure the pressure everywhere, because then we will be able to see optimal production targets.
Yes, that's right. We need to target all the zones.
What is the cost to survey 18 wells?
This will total to 1,800,000 rubles.
It seems to me that it is optimal way to spend part of the funds at the beginning in order to determine the formation pressure and understand what to do next.
Let's perform surveillance. Can you state the well numbers and specify the required number of days for a fully fledged surveillance?
By reviewing the interpretation, I propose to run it for 3 days.
I believe that these losses are not significant and they can be ignored.
106, 109, 110, 112, 114, 115, 116, 119, 120, 122, 123, 124, 125, 127, 131, 133, 135, and 137.
18 wells, 1,800,000 rubles. We have received the results and it is evident that there is a strong pressure drawdown in well 106, in well 109. On the southern dome, we can see that the reservoir pressure at well 119 is low. Especially low pressure can be seen at well 120, 122, 123, at 78 to 79 bar, and requires reconstruction. Also, wells 125 and 127.
How do you plan to increase the reservoir pressure?
We already have preliminary surveillance results. According to the specification, it is also necessary to reconstruct the cement sheath and transfer the wells to injection.
A specific list has already been created as a part of the development strategy document.
We can convert to the injection wells 123, 129, 114, and 112 on the southern crestal area, and perhaps well 136. The list can be adjusted as needed. Perhaps other wells will be more cost-effective here. We agreed that it is necessary to reconstruct reservoir pressure on the northern crestal area, and the converted in the injection cannot be short-circuited. We have not yet heard the economist, who has just completed the calculation of the economic efficiency. Economist, please report.
Here are 2 examples for well 126. The first one is regarding perforation. The second shows water gas shut-off plus perforation. Here we can see that PI is higher if we perform water gas shut-offs plus perforation.
Do these wells have the same production targets?
No, absolutely not.
But PI does differ slightly.
This is still designed for 1 year, isn't it? We can calculate the values for use later down the road. And in this case, the values of PI and NPV would be 1.5 times higher. I believe in 2 years the effect will be in favor of water-gas shutoffs plus perforation.
Do we need to calculate 5 years ahead, or is the trend evident?
Will the production rate change within 5 years?
It will vary during the development process.
I suggest we change the value at each year.
I propose to calculate and create a strategy for the 5-year plan, since we will apply the result on a number of wells. We also wanted to convert wells to injection. What do you think?
I fully support the idea to convert the wells to injection.
Will we have enough funds to drill the wells?
It all depends how many activities we have. If I am not mistaken, the pressure maintenance conversion will cost 6.5 million rubles. I have already managed to sum up pressure maintenance conversion for 6 wells, and that will cost us 39 million rubles. Currently, we have 127 million rubles. If we spend 39 million rubles, we will have 88 million rubles remaining, which in turn will allow us to drill 1 vertical well, perform a full logging suite, as well as performing some activities at primary wells.
Will we have enough funds for other activities?
I just mentioned this. There will be enough funds left on the primary wells.
I got a question. Will we drill a producer or injector well?
It all depends on which zone is most promising. I believe that we should try and drill an injector well on the northern crustal area in order to reconstruct reservoir pressure, since we expect that during the second shot we will drill a producer wells there. Perhaps even an injector based on the drilling results of the first well, determining the dip of geological structure and understanding how we will place the well.
I support it. Does everyone support this strategy?
Yes, it does.
Then it turns out we act according to the plan. We converted 5 wells to injection on the southern creston area.
Perfect. Then let me share my screen so that you can see how we input the data and perform activities regarding the conversion of wells 112, 114, 123, 129, and 136.
Regarding the conversion of well 132 into producer, are we going to review this as a separate case?
We will review this separately. It is very likely that it will return back to the producer, provided that it had a significant oil production rate, and when it was converted into injection, it did not focus on target sublayers.
Is it located at the very center of the remaining reserves?
Exactly. The graph provides us with a sufficient amount of data, and we are certain that there are significant amount of reserves there.
So we convert well 136 into injector?
Yes, it does.
This makes sense.
So, team, do you all agree with the list of candidates that are to be converted to pressure maintenance? If you agree, then let's get started.
I have a question. Do we actually need the well 123? It has a low water cut. Why don't we consider wells 120 or 126? And is it necessary to convert well 136?
This is why I propose to convert these wells to injection, in order to only compensate production of well series 125, 126, 127. B2 sublayers are missing there. We plan to inject into this formation.
Well 126 is currently operating higher than wells 125, 127, 123, 118, 119 combined. This is an obvious thief injection and a problem with channeling or perhaps something else.
We see that it targets layer B1. We want to enter B2 pay zone and compensate the pressure.
What if we take a look at the channelings and find out which wells need to be converted, so it is certain that the injection will go there?
I understand that in any case we would like to perform water-gas shutoff first, So, that all the target injection is directed to B2 and not to B1. Is that correct?
So we will perform water-gas shutoffs before the conversions. Perhaps it is not correct according to the methodology, but what if we perform water-gas shutoffs both at the top and bottom without reservoir flow profile? Is that feasible?
I believe the production logging specialist can comment more on that.
We are currently planning to convert a number of wells in the southern block to injection, specifically wells 112, 114, 123, 129, 136, in order to maintain the reservoir pressure, which is very low. We do not want the thief injection to go into the unproductive layers A and C. We wanted to make sure that we do not have channelings. But there is also another element of the strategy. We would like to shut off the formation B1, which contains a highly permeable sublayer that allows to fully optimize the production targets at producing wells. I do have a question. Without production logging data, can we start blindly performing water shutoffs from the top and bottom, as well as targeting a highly permeable layer? Or this will be impossible without the reservoir flow profile?
Can you state which wells you have in mind?
112, 114, 123, 129, and 136.
If we want to isolate the formation unit B, then there should be no problem. We can isolate it a little higher. Polyplan will understand that we are isolating the overlaying layer. However, I don't know about the bottom layer. There were no crossflows there before. Not only do we have to isolate the existing crossflows, we need to prevent the new crossflows from occurring, so that the pressure difference between the bottom hole pressure inside the well and the reservoir pressure in the water-bearing formations does not exceed the limit. Otherwise, whatever crossflow we isolate now could happen again later down the road.
And this was the main reason why we wanted to isolate layer B1 completely, not just the highly permeable sublayer, so that we don't need to look out for possible channelings. Unfortunately, we cannot control the bottom hole pressure, we can only control the flow rate, and therefore we need to know the productivity coefficient, so that we can set up the right flow rate where the channeling would not occur. I believe we have this information.
The productivity values already include layer B. If the flow is from the layer B, it is necessary to correct it based on the reservoir conductivity, according to the open hole data, so that we recalculate the injectivity and set the correct wellhead pressure.
I would like to hear what simulation engineer has to say about this.
Yeah, sure. Just to clarify, are we talking about the feasibility of isolating the unit B1 without the reservoir flow profile? Let's take open hole data, formation pressure data, and statistics on offset wells. Here we see a problem with offset wells. Either a part of the teeth injection goes to the unit A, or all of the injection or all of the production comes from the unit B1 at the top of the formation. This raises a question. Can we finish adding perforation to the unit B2 and simply putting into operation at optimal production targets by lowering the bottom hole pressure as much as possible? Based on the production history of offset wells, can we say that the wells which we don't have production logging data behave the same as those wells with production logging data? Therefore, our strategy assumes that currently the entire unit B1 is isolated, because the top of the formation is the main part of this unit and is separated by a very small barrier and by unit B1. If we simply isolate the top of a formation, is it 99% guarantee that we'll break through this unit again? Therefore, I propose to isolate the unit B1 and produce only from the unit B2. What do you say?
So I have decided to go ahead and apply this data. Then we are not going to perform any reservoir flow profile and will proceed to isolate all the wells. I have a question. There are 5 wells that we are converting. Do we need reservoir flow profile, or should we begin water shutoffs right away?
If we look at the open hole data, that is evident that we can perform water gas shutoffs of the upper sublayer right away, and we can convert it to maintain pressure. Later during the shot, Based on the results of the response, we can identify the wells that have abnormal injection and, based on the well data, perform reservoir flow profile. To find out if we need to perform reservoir flow profile at the bottom.
Are we going to perform water shutoffs, or are we just doing the conversion?
I suggest we convert it to maintain pressure and at the same time isolate the aquifer and the formation B1 completely.
So we perform this on all 5 wells.
Yes, it does. And concentrate on the layer B2.
Does everyone agree?
Keep in mind that we must finish adding the perforation to offset wells at unit B2, and we also need to deal with those wells that are already injecting. The same procedure should be performed on them.
I would like to note that as soon as we add the perforation and perform water shutoffs, first we will need to measure the reservoir pressure at these wells, and then we can convert it.
I absolutely support this decision, at least for the reference wells.
We can begin the activities if we will have enough funds left. We will drill some wells.
Beginning pressure maintenance conversion for wells 112, 114, 123, 129, and 136. Is the well candidate list correct?
Yes, correct.
Okay, it's done. Now we need to perform isolation. Petrophysicist, please specify the intervals.
Well 112 from the wellhead to 1670. 114 from the wellhead to 1669. 123, 1633. 129, 1650.
So, well 136 it is. Tell me please, which layer of the main formation is connected to the formation B1?
The unit B1 is connected to the main unit B2.
So, we should not shut off the B1 formation in well 136, right?
Correct.
Can you tell me, please, whether the actual production target of well 136 matches the calculated value?
Yes, it does.
I suggest we isolate the layer B1.
I recommend leaving the current intervals, and let's choose the optimal production target.
Copy that. So, we are approving the activities? Okay, it's done. Now we need to perforate layer B2 at the southern dome.
We need to start with the wells where the water gas shutoffs were already performed.
112 intervals 1670 to 1675. 1680 to 1682. 114 1669 to 1680. 123 1633 to 1654. 129 1650 to 1670.
Done.
What about well 136?
The layer B2 there is not connected with the others and is irrelevant.
Well 136 influences well 132. Will there be an influence on a small dome south of well 136? Which unit is represented on this dome? B1 or B2? Perhaps we can finish adding the perforation to the unit B2 at well 136.
Won't the fact that these zones are located far away from each other pose any problems?
We need pressure maintenance.
Team, what is your opinion?
It makes sense when we will be later performing drilling at the zone. Can we do this on the next shots?
Given that the distance is too far and we are still awaiting for response, it is necessary to perform the perforation right away.
One last question. Are there no boundaries or faults there?
I asked the geologist to join the discussion. We need to extend the south.
If you look at the seismic, then we might be a connectivity between B1, but this is still yet to be clarified.
So, team, I still propose to cancel the perforation of formation B2 at well 136, as the distance is too high and there is a chance that we will lose the injection through edgewater. I propose to concentrate the injection of this well into formation B2. which is located at the main southern dome.
If the units are connected, the pressure wave will reach it, and if we're going to perform drill, then it might be a good idea. As far as I can see, there are no boundaries.
As far as I remember, the field development plan of this area provided by Reservoir Engineering regarding the undeveloped reserves includes drilling 2 wells, an injector and a producer. And if instead of one injector well, we instead perforate well 136, it will be much cheaper to maintain pressure at this undeveloped area.
And if the drilling results will show that there are no reserves in the southern undeveloped area, then the injection will miss the target. We don't have the actual data. It's all estimates.
Can anyone tell me, does well 130 penetrate pay zone B2?
On the screen, you can see the open hole logs of well 130. B2 has entered the pay zone completely.
Perhaps it is best if we add perforations.
Let me clarify. The main dome formation B2 is connected to the formation B1 of the western dome, and we are talking about the formation B2 of the western dome.
Part of the injection will still go into the formation B3 at the main dome.
If I'm not mistaken, the layer B3 of the main dome is water saturated. There is one question that remains regarding the entering layer B2 into pay zone at the main crustal area.
Instead of drilling the well, let's finish adding the perforation to all of the missed zones.
And we will spend the remaining funds on the northern dome. There will be enough funds for a couple of activities to restore the primary wells.
Maybe we should drill more after all.
Perhaps we should start with workovers. This is more beneficial than anything else.
We will start by adding the perforation to well B2 at well 136.
The interval is between 1670 and 1685 meters.
Applying the perforation. Done. Let's continue. The layer B2 did not enter pay zone at wells 115, 118, 119, 120, 125, 126, and 127. I have an approximate interval. However, petrophysicists may have a more precise information.
Are we going to perform water gas shutoffs?
We have only performed water gas shutoffs for the wells that were converted to injection.
Perhaps we can perform water gas shutoffs on the injector wells in this zone, and only then make the perforation.
Perfect.
If you name the well, I can state the intervals.
Well 117, water gas shutoff from the wellhead up to 1645 meters. Well 122, upward crossflow.
Petrophysicist, can you please specify the depth? I would like to note that we are also isolating the layer B1.
From the wellhead up to 1625 meters.
The next well is E3. We have already surveyed in during this shot.
Isolation from the wellhead up to 1620 meters.
The next one is 132.
The same goes here, up to 1620 meters.
Just a second. The economist has finished the economical calculations. So, by reviewing the results, we can see that even with a lower production rate, in 5 years we have a significant production increase.
So we have the right strategy, so let's continue to follow it.
In well 132, let's perform water gas shutoffs up to 1620 meters.
All right. Tell me what are the next wells?
There are 3 more producers, 103, 108, and E4.
We also need to add well 127, up to around 1625 meters.
Done.
We also forgot well 128. There is a production logging data for it. However, the situation is rather controversial. Take a look at the result.
I propose we try to isolate just the layer B11.
I support this decision.
I suggest to isolate it up to 1615 meters, so that the lower part will be still in operation and the upper part was shut off.
Tim, I'd like to add to what was already said regarding 138 well. If we want to avoid a breakthrough at layer B1, the bottom hole pressure should be at least 120 bars.
Perfect. So, team, we are now going to isolate layer B1 and compare the production target of the well with previous years to understand how will the quantity of the liquid inflow from the layer B1 change if the inflow, instead of going through the perforation intervals, went through the behind casing cross flow. If this will not work, we will shut off the layer B1 completely.
Yes, sure.
Based on the result of the first shot, we will understand whether it works or not, and then we can perform the activity on the rest of the wells.
Perfect. Have we completed all operations on layer B2?
No, we haven't finished yet. Let's open Polyplan and go well by well. 112. B2 entered the pay zone. 113. Entered the pay zone. 114. Entered the pay zone. 115. Did not enter the pay zone, but it is located close to oil-water contact.
It might be a good idea to enter pay zone through intervals 1650 to 1665.
All right, let's move on.
116 entered the pay zone. 117 entered the pay zone. 118 1640 to 1657. 119 1637 to 1655. 120 1642 to 1654.
When we will finish off with the layer B2 and we will run out of funds. Is everyone aware?
121 entered the pay zone. 122 1626 1645. 123 1633 1654. 125 1622 1640.
There are not enough funds left. I propose to abandon part of the perforation.
For the well 125, let's leave only the perforation 1630 to 1640. 126, 1640 to 1649. 127, 1654 to 1659. 1660 to 1670. 129 entered the pay zone. The rest of the wells are drilled to develop reservoir unit B.
We have the number of activities aimed to perforate reservoir unit B2 to the south of the main dome. We do not have enough funds. We need to abandon some of the activities.
Let's abandon the well 115. 50 meters of perforation and unclear potentials. 119, we can reduce the perforation interval to 1638 to 1640.
It is not enough. We also need to reduce the perforation at the remaining wells.
I offer well 118.
118, 1640, 1647.
Do we approve?
Let's restore a part of the perforation at 115.
115, 1653, 1655.
So, we are approving the activities?
Yes, it does. So we are left with production targets.
There has been a change in the downhole pressure. It's necessary to take it into the account.
Can you please state the wells?
Let me first state the pressure at producers. 120th, 122nd, and 130th. You can reduce the pressure to a minimum.
I suggest going in ascending order.
From 103rd to 119th inclusive, 61 bars constant. 120th, 45 bars. From 121st to 130th inclusive, 61 bars. 132nd, 45 bars. 133rd and 134th, 61 bars. 138th, 45 bars. and E4th well 61 bars. Next, the injector wells. 101st and 102nd and 107th 258 bars. 112th well 436 bars. 113th well 248 bars. 114th well 436 bars. 117th and 122nd, 123rd 450 bars. 124th, 131st, 135th, 136th wells 248 bars. 138th well 450 bars, and E3rd well 450 bars.
I've finished the calculations. If you can state clearly the number, I will provide you with its production target.
Let's start with the injector wells.
101, 180. 102, 320. 107, 400. 112, 150. 113, 400. 114, 180. 117, 200. 122, 300. 123, 500. 124, 340. 129, 480. 131, 320. 135, 440. 136, 500. 137, 280. E3, 260.
Done. There is not enough funds to convert well 132 to a producer. I suggest to keep it shut in for a year.
Perfect. If we leave injector wells with high injectivity, there could be a water cut.
I agree. Let's decrease the injection from well 102 to 100 cubic meters per day. 107, 150. 113, 200. 123, 300. 129, 200. 135, 300. 136, 300.
Now regarding the producer wells.
103, 130. 104, 50. 106, 45. 108, 20. 109, 40. 110, 60. 111, 78. 115, 68. 116, 40. 118, 76. 119, 60. 120, 110. 121, 73. 125, 93. 126, 35. 127, 85. 130, 42. 132, 83. 133, 73. 134, 30. 138, 25. E4, 80.
I propose to stimulate the production for well 138 to test our hypotheses about the inflow from reservoir B1. I suggest we leave the production target at 83 meters cubed per day.
Although it had a skin damage of plus 20, it produced about 40 cubic meters of oil.
Then we said 88 cubic meters per day.
Done. Should we place the shot?
That's right.
Well, let's now take a look at the data room to see the field response.
What is the budget as of now?
74 million rubles.
It is necessary to convert well 132 to a producer.
Yes, and perhaps we should drill at this undeveloped area. Now let's look at the bottom hole pressure at every well.
101. A well with auto-hydraulic fracturing. We reduced water injection rate. 102. Similar situation. 103.
We have constricted it, resulting in increased flooding.
Because this is channeling.
Yes, that's right. This is channeling in action. There is a small increase in production rate at well 104. At well 106, the production rate also increased. It was channeling observed at well 107. Well 108 did not begin producing. We need to perform reservoir flow profile and water gas shutoffs.
We have already done the reservoir flow profile for 108.
Great. Then we perform water gas shutoff right away.
109 is doing a good job.
We have received a good response. 110 continues to operate at its current production target.
Can I clarify one moment? Did the flow rate of well 109 match the forecasted flow rate? We need to discuss this matter with a simulation engineer.
Bottom hole pressure is 61 bar. Production rate is 37 cubic meters. In fact, the liquid production rate is 40 and oil production rate is 30 cubic meters per day.
So there is a match. What is the water cut?
It's the same.
110 operated at its current production target.
It's possible to increase the production target. We are not going to do anything with this zone anymore.
Yes, we need to increase the production. 111 continues to operate at operating mode. We can further increase production rates. 112 converted to injection and have received a bottom hole pressure of 400 bar. The injection graph is very peculiar. It is fully operating on layer B2. 113 operates without water gas shutoffs. The bottom hole pressure is growing. 114 fully converted to maintain pressure. 115 is a producer. We see a significant increase in downhole pressure. The response from offset pressure maintenance, conversions, and from the injection into the target layer B2.
Is it possible to see the model forecast based on well 115?
The injection bottom hole pressure inside well 115 should be 61 bar at the beginning, and the pressure should increase from injection. However, the water cut is 86%. The only thing is that concerning the launch date, there is no increase in reservoir pressure. That is, there is no response that the reservoir pressure has begun to increase. And it's evident that the reservoir pressure exists, and we can increase it further.
So there is potential there, right?
There is a potential, but we have not yet shut off unit B1 there.
Yes, I see a breakthrough.
So, shows unit B1 working?
That is, we have a number of wells that still need to be optimized. Shut off B1?
Yes, it does.
Excellent. Do you think it's just the pressure is increasing, or is it channeling?
It seems to me that this is the pressure along the unit B1, and the total pressure in this zone is rising.
I would like to ask reservoir engineer what would be our strategy. Are we shutting off B1 entirely just on the southern block?
Let's finish reviewing it first, and then we will develop a strategy.
Okay, I agree.
The same is happening at well 116. A significant increase in downhole pressure and water cut.
In regard to well 116, as I believe, we also didn't shut off anything. This concerns the issue where all the water flows in through a high permeable subunit.
So you believe this is definitely not channeling?
I believe not.
All right, let's continue. Have we performed water gas shutoffs at 117?
We have performed it on this well, and only the unit B2 is operational.
The production rate was increased at 118. Operates on B2. the pressure is increasing and can be further stimulated. Similar situation for well 119. Similar situation for well 120. Similar situation for well 121. But the stimulation was small. It is possible to increase it further. For well 122, the injection bottom hole pressure is at 400 bar, operating at its maximum limit. 123 similarly converted to injection. The injection bottom hole pressure is at 400 bar, which creates a good pressure in the reservoir B2. There is an interesting growth at well 124. Can anyone recall whether or not it just operates on reservoir B2?
No, it operates on all units.
Therefore, we can see that the pressure increase. 125 works on B2, similar to other wells. Good, significant reserves are involved. It is necessary to intensify. 126, similarly intensify. 127, the same thing. 129, from the same series of injection wells. 130, slightly different from the others, an increase in water cut has begun. 131, presumably other layers are at play. 132, we stopped it on purpose. Now we will get it back in production. 133, there is an increase in downhole pressure. It is interesting that the water cut has increased. Perhaps it is a reservoir water.
Have we not closed B1?
Most likely, this is the work of B1. 134, a sharp jump in water cut, which has further decreased. 135, an interesting response of the injection bottom hole pressure, but it seems to have stabilized. 136, I remembered. 135, 136 is a separate left crestal area, which is connected through layer B1 to B2 of the main crestal area. Therefore, the performance of 135 and 136 is similar. 137 pumps in B2 at the maximum possible pace. 138, B1 was isolated. An interesting response. At the moment, the channeling for B1 did not occur in B1, which can be seen due to the absence of pressure.
Have we completely closed B1?
No, only B1. A small interval of 2 meters of the formation B1 remained in operation. E3, the injection was maximally intensified. E4, the work of the channeling, which explains such a water cut. Now, we will fix this area, and we will get oil. The review of the response is completed. We now need to intensify the production of B2 in the south on the northern crestal area. The treatment of leaks, the restoration of reservoir pressure, and drilling.